In this question, you can see that there is a object of dome shape, and the total volume of this object is V, and the density of a liquid is rho, and the bottom of this object is flat, which has a cross-sectional area of A. The bottom is situated at a depth of h from the surface of the water, and top is of dome shape. So we have to find out the total force applied by this liquid on the top surface, which is dome surface, and also we have to neglect the atmosphere. So we know that the buoyancy acting on this object will be V rho g, obviously, and the buoyancy is and the force applied by the liquid on the bottom is F1 in the upward direction, and the force applied by the liquid on the top is F2 in the downward direction, and obviously F1 is greater than F2. So buoyancy, which is also the resultant of these two forces, can be written as F1 minus F2, and therefore F2 can be written as F1 minus buoyancy. Now F1 is the force acting on the flat surface, so the pressure at the flat surface is H rho g, and the force will be H rho g A, and buoyancy will be V rho g. So this force is acting on the top surface in the downward direction. So the correct answer is B. Now we move on the next question. In this question, you can see that there is a light balloon which is formed of massless material. It is filled with helium gas, and the density of the helium gas is rho He. And this balloon is tied to a light string of length L, and this string is connected to the ground, and this is forming a inverted pendulum. Now this balloon is slightly displaced like that, so that it performs simple harmonic motion. So we have to find out the time period of this motion. We know that if we draw the free body diagram of the balloon, then buoyancy will be acting on the upward direction and mg would be acting in the downward direction. And obviously for SHM it is necessary that a string should be taunted, and for string to be taunted it is necessary that buoyancy should be greater than mg. Now the value of buoyancy will be equal to V into density of air into g, and the value of mg will be equal to V into density of helium into g. So the net force is buoyancy minus mg, and this is mg effective. So this is Vg and rho of air minus rho of this helium gas. This is helium rho He. So rho He, and this is equal to m. So m is the mass would be volume into density of helium into g effective. So you can see that g effective is equal to g into rho air minus rho helium divided by rho helium. Okay, and this is g effective, and we know that the time period of this pendulum would be 2 pi under root of L by g effective. So time period will be equal to 2 pi under root of L by g effective is rho air minus rho helium upon rho helium. So you can see that the correct answer would be, and this is G also, so the correct answer would be option D. Now we move on the next question. In this question, you can see that there is a thin plate that separates these two liquids of coefficient of viscosity neta and 4 neta respectively, and there is a movable plate in between them which is to be pulled by applying a minimum force. then we have to find out the value of d2 by d1. So we can easily imagine the situation that the force which is required to pull this plate with some constant velocity will be equal to the viscous force of liquid 1 plus viscous force of liquid 2. So this force will be equal to neta into A is the area, and dv, let us suppose that the velocity of the plate is v, so dv by dz is d1 plus this is 4 neta into A into v by d2. Okay, so F will be equal to neta A v is common, and this is 1 by d1 plus 4 by d2. Now we have to minimize this force. So what we should do, that we should use the maxima minima. So let us differentiate it by maxima minima, and we know that if this distance is d, then we can replace d1 by d minus d2. So F will be equal to neta AV into 1 by d minus d2 plus 4 by d2. So dF by d2 should be 0. So this is neta AV, and the differentiation of this will be 1 by d minus d2 whole square into minus 1. And let us do it on the next page. Let us write down the expression on the next page. So F is equal to neta AV and into 1 upon d minus d2 plus 4 upon d2. So dF by d2 dd2 will be neta AV into differentiation of this one. So differentiation of this expression would be minus of d minus d2 whole square into minus d2. So into differentiation of minus d2. So differentiation of minus d2 with respect to d2 would be minus 1. So this would be plus, and this is minus 4 upon d2 square, and differentiation of d2 is 1. So this is 0. So 1 upon d minus d2 whole square is equal to 4 upon d2 square, and d minus d2 upon d2 is equal to 1 by 2, and d by d2 minus 1 is equal to 1 by 2, and d by d2 is equal to 3 by 2. And we know that d is equal to d1 plus d2. So d1 plus d2 upon d2 is equal to 3 by 2. So this is d1 by d2 plus 1 is equal to 3 by 2, and d1 by d2 is equal to 1 by 2. So the correct answer of d2 by d1 is 2. So the correct answer is B. Now let's move on the next question. In this question, you can see that there is a coating process in which there is a thin flat tape whose width is W and whose length is L, and this flat tape is being pulled through this channel containing a Newtonian fluid whose density is rho and whose dynamic viscosity is mu. And this fluid is in contact with the sides of the tape, and this width of this tape is much thinner as compared to the edge, so we have to assume it negligible. So we have to find out the force required to pull this tape with a constant velocity of v. So now let us assume, we are assuming that this width of this tape is negligible as compared to h, and therefore we can say that this distance is h by 2 and this is h by 2. Okay, so we know that the viscous force on any one side on the upper side, let's suppose this one, there would be two viscous forces, and first is this one and second is on the bottom side, like that. So the value of any one viscous force F will be equal to mu A into dV by dz, and F will be mu, area is L into W, and dV is V, and dz is h by 2. Okay, and there are two forces, so the total force which we require, minimum force which we require to pull this tape is 2F, so it would be 4 mu L W V by H. So the correct answer would be option A. Now we move on the next question. In this question you can see that there is a thin walled hemispherical shell of mass small m and its radius is r. This shell is pressed against this smooth wall, and through a very small aperture on the top, a water of density rho is filled into the shell completely. We have to find out the minimum magnitude of force that is to be applied on this shell so that liquid does not escape from this shell. And it is given that weight of the hemispherical shell is mg, and the total mass of the water in it is 2 by 3 pi r cube rho, obviously, because this is the volume of hemisphere and this is the density of water. This is m. Now we know that if we see the cross-sectional view of the covered area on the wall, then it would be a disk. Okay, you can imagine that this hemisphere is being pressed against the wall and the area it is covering on the wall is disk. The disk has a radius of r, capital R, and the force which we need to apply on this hemispherical shell, the horizontal force, is the pressure of the liquid on the wall. So let us suppose that liquid applies a pressure of P on the wall and a force of F on the wall, and wall will give the normal reaction back to the liquid, and this liquid applies that normal reaction on the hemispherical shell, which should be balanced by our horizontal component. So the horizontal component of force applied by us on the shell should be equal to the force applied by the water on the wall. So we know that this force would be the average pressure into area. Now average pressure would be the pressure at the top, which is 0, the pressure at the bottom, which is 2r rho g, because this height is 2r, so this is 2r rho g, and into area. Area is pi r square, and average pressure would be top pressure plus bottom pressure divided by 2. So F would be equal to r rho g into pi r square. So F would be equal to pi rho g r cube. Now you know that pi rho r cube is 3 by 2 mg. So F is equal to 3 by 2 mg. Okay, so this is the horizontal component of force, and the vertical component of the force would be equal to m plus mg. Obviously, we have to balance the mg of both of them. So the net force would be equal to under root of, let us use a new page. So net force would be equal to under root of F vertical ka square plus F horizontal ka square, and F vertical is equal to m plus mg, so taking out g common, and under root of m plus m whole square plus this 9 by 4 m square. So it is g under root of m square plus m square plus 2mm plus 9 by 4 m square. Okay, so you can see that this we can write it down as Okay, we can use this one because answer is given in terms of this one. So you can see that if we take out mg common, then it would be 1 plus m by m whole square plus 9 by 4. So we can say that one correct answer is B, and the vertical component of the force will be m plus mg. So C is also correct, and the direction of force is given by this. So let us see that F horizontal is equal to 3 by 2 mg and F vertical is equal to m plus mg. So the direction of force measured from the horizontal direction, like that, this is F horizontal and this is F vertical and this is theta. So tan theta is equal to F vertical by F horizontal. So F vertical by F horizontal is m plus m upon 3 by 2m. Okay, and you can see that this is incorrect. Okay, and therefore the only correct answers are B and C. Now we move on the next question. In this question, you can see that there is a small ball which is held in the container at this point A, and the ball has a density of rho and the liquid in the container has a density of 4 rho. Now this container is closed and it is being completely filled, and this container is being accelerated in this side with the acceleration of A. The length of the container is L and this length is L also, and this is L by 2, L by 2, and we have to choose the correct option. Now all the 4 options says that this ball will strike the point Q. So we have to examine this fact. So let us draw the free body diagram of the ball. We know that due to pressure difference, a force will be applicable on the ball which is called as buoyancy, and buoyancy will be 4 rho g v, where 4 rho is the density of liquid, g is g, and v is the volume of ball, and mg of the ball would be acting in the downward direction, which is rho g v. And due to pressure difference in x-axis, you know that as this container is moving along x-axis, there would be a pressure difference generated on the two sides of the ball. So due to that pressure difference, a force will be generated in the forward direction, and this force will be equal to 4 rho av, where a is the acceleration of the container, and the pseudo force ma acting in the backward direction is rho av. So we can see that the net force acting in the upward direction is 3 rho gv, and the net force acting in the forward direction is 4 rho av. In fact, 3 rho av. Okay, so the resultant force is this. So you can see that the tan theta will be equal to 1. In fact, not 1, it would be 3 rho gv divided by 3 rho av. So tan theta would be equal to g by a, and this tan theta would be equal to 1 by 2, because you can see that tan theta is L by 2 upon L. So this is 1 by 2. So a will be equal to 2g. So the acceleration of the ball will be 2g. In fact, the ball will hit the point Q if a is equal to 2g, and the time we can easily calculate that the time it would take to move in the upward direction by a distance of L by 2 is obviously the same time in which it will strike the point Q. So S is L by 2 and it is half A. Now the net acceleration in the upward direction would be net force, which is 3 rho gv upon m. So acceleration in y will be 3 rho gv divided by mass of the ball, and mass would be density into volume. So the acceleration would be 3g. So half into 3g into t square. So t will be equal to L upon 3g root. So the time in which this ball will strike the point Q will be under root L upon 3g. Now we move on the next question. So the correct answers are B and C. In this question, you can see that there are two bubbles which are touching each other and they are coalescing with each other, and the common interface formed between them is not broken. If there are two tangents which are drawn on these two surfaces, and we have to choose the correct option. So the first option says that alpha is 120 degree if r1 is equal to r2. Now first of all, we know that the radius of common interface would be 1 upon r is equal to 1 upon r1 minus 1 upon r2. So r will be equal to r2 minus r1 upon r1 r2. This is the first formula. Now the other thing which is important is the fact that you can see, we always know that this alpha is always 120 degree because the material of the soap film material of these two bubbles is same obviously, and if we consider a small element dl, then equal forces would be acting in all three directions on dl, t into dl, t into dl, t into dl. So three equal forces acting in three directions would be in equilibrium if alpha is 120. So in irrespective of the value of r1 and r2, alpha will be equal to 120 degree. So the correct answers is A, C and D. Now we move on the next question. In this question, you can see that there are two ice cubes of side 10 by 10, and they both have a cavity at the center whose volume is 20 centimeter cube, and these two ice cubes are being floated in two vessels which are having initially the same level of liquid, and now liquid is water obviously, and the specific gravity of the material of A is 4.9 and the specific gravity of the material of B is 1.9. Now these ice cubes starts to melt uniformly and at constant rate and same rate in both the vessels. We have to choose the correct option. Now first of all, we have to find out the ratio of immersed volumes of these blocks in A and B. So we know that buoyancy is equal to V immersed into rho of liquid into G, and buoyancy is balancing out mg in the floating condition. So let us see that for A and for B, so buoyancy for A is V1 into rho of liquid into G, and we know that this liquid is water, so rho is 1 and this is G, and this is equal to mg. So mass would be equal to the mass of ice. Now you can see that the total volume of this ice cube is 1000 centimeter cube, out of which 20 centimeter cube volume is occupied by cavity which is filled with the material A. So the remaining volume is 980. So in 980 there is ice and the specific gravity of ice is 0.9, plus in 20 cc of volume there is another material A which has the specific gravity of 4.9. Okay, this is the total mass of the floating ice cube A, and this is G, cancelling this G with G. Similarly, V2 will be equal to 980 into 0.9 plus 20 into the specific gravity of B is 1.9. So this is 1.9. So you can see that it would be 980 into 0.9 and 20 into 4.9. This is equal to 980. and this is equal to 38 plus 882. This is 920. So the ratio of immersed volume is 98 by 92. So it is 49 by 46. So the correct option is A. And among C and D, we can see that obviously the weight of this material A is greater than the weight of the material B. So the A will start to sink before B. So you can see that this line denotes that at this point A starts to sink, but B hasn't started the sinking. But in this graph, at this line, A and B both have started to sink. But we know that as A is heavier than B, so A will start to sink before B, as ice is melting at constant rate, and that rate is equal to both of them. So we can say that A will start to sink before B, and therefore the correct answer would be C. So the correct answers of these questions are A and C. Now we move on to the next question. In this question, you can see that there is a pipe which is placed in the horizontal plane, and the liquid is entering this end of the pipe with a velocity of 4 meters per second, and the area of cross section of this end is 0.2 meters square. The pressure at this end is equal to 280 into 10 raised to power 3 Newton per meter square, and the area of this cross section is A1 by 4. So we have to find out the pressure at point Q, and we have to find out the force acting on this pipe. So we can easily see that we have to apply first of all the continuity equation to find out the value of V2. So we can say that A1 V1 is equal to A2 V2, and A2 is equal to A1 by 4. So this is A1 V1 is equal to A1 by 4 into V2. So V2 is equal to 4 V1, and therefore V2 is equal to 16. Now we can apply the Bernoulli theorem between these 2 points 1 and 2. So at point P, the pressure is 280 into 10 raised to power 3 plus this is 280 into 10 raised to power 3 plus half rho into 4 square, and it is equal to the pressure at Q plus half rho into 16 square. So you can see that PQ will be equal to 280 into 10 raised to power 3 minus of taking out common half rho, and this is 256 minus 16. So this is 240. So PQ will be equal to 280 into 10 raised to power 3 minus half rho is given as 0.9 into 10 raised to power 3, and this is 240. So this is 12. So PQ will be equal to 172 into 10 raised to power 3. So the correct answer is A. Now also we have to find out the force required to hold this pipe. Obviously the external force required to hold this pipe will be the force applied by the water on this pipe. So we can easily calculate that force. We can see that there would be, this is the pipe, let us draw the pipe. This is the pipe. So no, let us draw again. Like that, okay, somewhat like that. So you can see that one force will be acting in this direction because water is entering in this direction, and one force from this end water is leaving out. So one force would be acting in this direction like that. This is F1 and this is F2. Now you can say this angle is 37 degree. So this angle would be 37 degree. So this is 37 degree. So F1 will be equal to rho into A into V square. This is the general formula. So for F1 we can say that rho is rho, area is A1 into V square. V is 4, so this is V1 square. So F is equal to 0.9 into 10 raised to power 3. Area is equal to 0.2 and V1 square is 16. So this is 16. So you can see that F will be equal to, this is 18 into 10 into 16. Okay, so it would be equal to, F would be equal to 2880. This is F1. And for F2 we can say that F2 would be equal to rho into A2 into V2 square. So rho is 0.9 into 10 raised to power 3. A2 is A1 by 4, I think. Yes. So this is 1 by 4 into, this is A1, which is equal to 0.2 divided by 4, and velocity is 16, so 16 square. So it is equal to 18 into 10 and this is 2, this is 64 into 64. So it would be equal to 11520. Now we know that the angle between these two forces is 37 degree. So the resultant force would be calculated by the vector addition, which would be under root F1 square plus F2 square plus 2F1 F2 cos 37. So by putting the values of these two forces, the correct answer would be 76 into 10 raised to power 3 newtons. So the correct answers are A and D. Now we move on the next question. In this question, you can see that there is a vessel of uniform cross section which is open at the top, and there is a orifice, a small hole at the bottom. It contains oil of relative density 0.8 and some water, and this vessel is being immersed in a large open tank which also contains the same oil. So we have to choose the correct configuration in which this water will not leak out and this oil will not go inside this vessel from this orifice. So this is obvious thing that if the pressure at this point 1 and the pressure at this point 2 is equal, then there would be no entrance or there would be no ejection of liquid from the vessel. So let us see that in the first configuration, the pressure at point 2, this is 2 and this is 1. So the pressure at point 2, let us write it down here. The pressure at point 2 is equal to P naught plus 15 rho g. Rho is 0.8 into g is 10. So this is P2 is equal to P naught plus this is 120. Okay, and the pressure at point 1 P1 is equal to P naught plus 5 into 0.8 into 10 plus this is 8 into 1 into 10. So this is 40. This is equal to P naught plus 120. So in the first configuration, the pressure inside and outside is equal, so water will not leak out. Similarly, you can check that pressure at point 1 in this second configuration P1 is equal to 12 into 0.8 into 10 plus 2.4 into 1 into 10. So this would be 12 into 8, which is 96 and this is 24, so it would be 120 plus P naught. So obviously this is also correct because outer pressure will remain same. And in this configuration you can see the pressure at point 1 P1 is P naught plus 8 into 0.8 into 10 plus 4 into 1 into 10. So this is 64 plus 40. This is not equal to the outer pressure. So outer pressure is greater. So this is incorrect. And in this configuration you can see that P1 is equal to 12.5 into 0.8 into 10 plus 2 into 1 into 10. So this 12.5 can be written as 25 by 2. So 25 by 2 into this is 8. So it would be 100 and this is 20. So this is 120. So the correct answers are A, B and D. Now we move on the next question. In this question, you can see that there is a container filled with water, and this container has a boundary which has an equation of y is equal to kx to the power 4. And there is a small hole at the bottom of this container, and water is leaking out from this hole. So we have to find out the time ratio of the time taken by the water to reduce to 3/4 from the initial level, and the time taken by the water to reduce to half from the 3/4 level. So we have to find out this ratio, and we have to report the value of this ratio as x. So let us assume that first of all this is the level at any instant, which is y, and this is x. So we can say that the area of this cross section is pi x square, and we can apply the continuity equation. So the velocity of liquid leaking out from this hole will be under root of 2gy, which can be obtained by velocity of efflux formula. So we can say that assuming that this hole has an area of small a, so we can say that a into under root of 2gy is equal to pi x square into dy by dt, where I have assumed that this liquid level is going down by a rate of dy by dt. The value of y is kx to the power 4, so this is a into under root of 2g kx to the power 4 is equal to pi x square into dy by dt. So you can easily see that the x to the power 4 and this is cancelled out. So dy is equal to dt, this is dt into a under root of 2g k divided by pi. Integrating both the sides, you can see that the limit of y will be h initial to h final. So h final minus h initial will be equal to t, this is 0 to t into, let's suppose this is c. So you can see that T1 would by T2 would be equal to h minus 3h by 4 and 3h by 4 minus h by 2. So this will be 1. So the correct answer of x is equal to 1. Now we move on the next question. In this question, you can see that there is a conical container whose bottom is like a small tap, and the water is entering from this tap with a velocity kt, which is variable with time. So we have to write down the formula of h as a function of time, and also we have to find out the x, where h is 3x when time is t is 1 second. So what we should do, we should first of all use the continuity equation. So we know that this diameter is very small, so the area of this hole will be pi d square by 4 and the velocity is kt, and this is equal to let us suppose that this is r. So we are assuming that r is very greater than d, so we are neglecting the d when we are calculating the r. So we can say that r by h is equal to tan theta, and tan theta is 1, it is given in the question. So R is equal to H. So the area of this cross section would be pi H square, and this is dy by dt, or y is H, so this is dH by dt. So cancelling pi with pi, so dH into H square, or we can write it down like this, H square dH integration will be equal to d square by 4 into k, which is 9, and this is t dt integrating. So this is 0 to it is also given that at t is equal to 0, h was 0, so 0 to t and 0 to h. So this is h cube by 3, and it is equal to d square into 9 by 4, and this is t square by 2. So h cube is equal to d square by 8 into 27 into t square. Okay, so the value of d is equal to 1 mm. So h cube is equal to 10 to the power minus 6 by 8 into 27, and time is 1. So h will be equal to 3 by, this is 2, and this is 10 to the power minus 2. So we have to compare it with 3x. So x will be equal to 0.5 into 10 raised to power minus 2, and this is 5 into 10 raised to power minus 3. So the value of x is 5 in mm. So the correct answer is 5. Now we move on the next question. In this question, you can see that there is a solid sphere of mass 2 kg, and the specific gravity of the sphere is 0.5. This sphere is held stationary with respect to this tank, and this tank is filled with water. This tank is accelerating in the upward direction with the acceleration of 2 meter per second square, and the tension in this string is found to be 8N. We have to find out the value of N. So let us first of all draw the diagram. Let us see that this is buoyancy would be acting in the upward direction, and pseudo force and mg would be acting in the downward direction, and also the tension would be acting in the downward direction. Now the buoyancy will be equal to V rho G effective, and G effective is G plus A. So you can see that T will be equal to buoyancy minus mg plus A, and buoyancy will be V rho of liquid into G plus A, and mass would be V rho of solid into G plus A. Taking out V G plus A common, and this is rho of liquid minus rho of solid, and this is equal to tension. So the liquid has a density of 1000, which is water, and solid has a specific gravity of 0.5. So V volume is not given. Okay, so we can say that the mass is 2 kg, so 2 will be equal to V into 500. So V is equal to 2 by 500, which is 1 by 250. So 1 by 250, and G plus A is 12, and liquid minus solid density is 500, and this is T. So T will be equal to this is 2, so T will be equal to 24 Newton, and therefore N, this N will be equal to 3. So the correct answer is 3. Now we move on the next question. In this question, you can see that there is a vertical triangular frame, and this frame is ABC, and this side BC can move vertically like that, and this wire always remains horizontal. There is a soap film formed on this frame, and the surface tension of this soap film is T, And this, if we know that if we pull this wire in the downward direction by a small distance, then it would execute the simple harmonic motion. So we have to find out the time period of this small simple harmonic motion. So what we will do in this question, that first of all let us find out this angle. So this angle is 30 degree because this is a equilateral frame, and when we will pull down this wire frame, then you can see that there will be a change, there will be an increment of the length. So let us see that we have pulled down this by a distance of y, and on the both sides the length has been incremented by a distance of x. So the total incremented length of this wire would be 2x, and we can easily find out the relation between x and y. So we can say that tan 30 degree will be equal to x upon y, and tan 30 is equal to 1 by root 3. So we have to find out the value of x in terms of y. So x will be equal to y by root 3. Now we know that the additional force is only the force which is responsible to perform SHM. So the additional force dF which is generated, and this additional force is also called as restoring force. This restoring force is the additional force acting on this additional length of the wire, which is 2x. So the additional force would be 2t. 2t is due to the fact that there is air on the front side and the air on the back side of this frame. So 2t into the change in length, which is 2x. So dF, which is the restoring force, will be 4tx, and dF will be equal to 4 into t, which is 3 into 10 raised to power minus 2, and x, which is y by root 3, and this is mass. Now this is the additional force generated. Now this force will be equal to m omega square y, where y will be cancelled out. So m is root 3 grams. So this is 4 into 3 into 10 raised to power minus 2 upon 3 into 10 raised to power minus 3. Okay, this is equal to omega square. So cancelling this 3 with 3, so omega square will be equal to, you can see that it is equal to 40, and this omega will be equal to, we have to find out the time period. So omega will be equal to under root 40, and this is equal to 2 pi by t. Now you know that root of 4 is 2 and root of 10 is pi. So this is also 2 pi, so this is 2 pi by t. So t will be equal to 1 seconds. So the correct answer is 1 second. Now we move on the next question. In this question, you can see that there is a glass capillary tube which is sealed from the upper end. The total length of this tube is 11 centimeters and the internal diameter is this one. This tube is being immersed vertically into a liquid whose surface tension is 5.06 into 10 raised to power minus 12. And when the length of the tube which is immersed in the liquid, this one, is x into 10 raised to power minus 2, then at this moment the level of liquid outside and inside the tube is same. So we can easily assume the situation, we can easily understand the situation, that let us suppose that this air has a pressure of P, and this point 1, which is just below this meniscus, will have the pressure equal to P naught because they are on the same level. So we can say that pressure at 1 will be equal to P naught, and pressure at 1 will be equal to P minus 2T by R. Okay, so we can say that P will be equal to P naught plus 2T by R, and P will be, P naught is 1.01 into 10 raised to power 5 plus this is 2 into T. Now T in this case is given as this 5.06 into 10 raised to power minus 2, and R is 2 r is 1 into 10 raised to power minus 5. Now I know that in this formula the r is the radius of meniscus and this r is the radius of tube. So I have assumed that angle of contact is 0 degree and the radius of meniscus and tube is equal. And we already know that in these cases when angle of contact is not mentioned, we always use the angle of contact as 0 degree. So this P will be equal to 1.01 into 10 raised to power 5 plus this is 2 into 5.06. So 5.06 into 2 is 1. This is 10.12 and this is 10 raised to power minus 2. So this is into 10 raised to power minus 2 divided by 10 raised to power minus 5. So this is P is equal to 1.01 plus 0.101, okay, into 10 raised to power 5. So this will be equal to, P will be equal to 1.1 1 into 10 raised to power 5. This is P. Now we know that that initially when the tube was not being immersed, then this complete column whose length is equal to 11 centimeters was filled with air and the pressure of air was P naught. And now the pressure of air is P and the remaining length is, let's suppose, L dash. So we can use the condition P1 V1 is equal to P2 V2, as we all know that in these kind of questions we can use this condition. So P1 is P naught into V. Now V is area into length and area would be cancelled out in these both terms. So we can directly use the length. So P naught into 11 will be equal to P into L dash. So this is P naught by P into 11 is equal to L dash. Now P is 1.11 and P naught is 1.01. So this is 1.11, in fact 1.01 divided by 1.11 into 11 is equal to L dash, and this is 1.01 divided by 1.11 is 0.9 and 0.9 into 11 is 9.9. So this is 9.9. So the length which is outside this liquid is 9.9. So the length which is immersed in the liquid will be 1.1. So this is L dash. L will be equal to, this L will be equal to 11 minus L dash. So 11 minus L dash will be equal to 1.1. So 1.1, this is in centimeters obviously. So we have to find out this in meters. So this is into 10 raised to power minus 2. So this is equal to, now if we equate this to x into 10 raised to power minus 2, x is approximately 1.1, so we can report it as 1, okay, in integer type. So the correct answer is 1. Now we move on the next question. In this question you can see that there is a pipe and liquid is flowing through this pipe steadily, and the pressure at the two ends is P1 and P2, and the velocity of the liquid on the axis is V naught. So the coefficient of viscosity of this liquid is neta, and we have to find out the velocity of liquid at a distance of r naught by 2 root 2, and we have to find out the value of n. So we know that in the case of a steady flow, let us first of all assume a small element. We can assume there is a cylinder of radius small r and as the flow is steady, we can say that the net force on this cylinder would be 0. So the net force due to pressure is P1 minus P2 into pi r square, and this will be equal to the viscous force which is acting on this cylinder in the backward direction. So P1 minus P2 into pi r square is equal to viscous force will be neta into 2 pi r into L into dV by dr. Okay. Now cancelling this pi with pi, so dV will be equal to P1 minus P2 divided by neta, and cancelling this r with 1 r, and this is 2 neta, and this is L, and this is r dr. Okay, so let us assume that this is constant C. So we know that on the axis on this point, on the outermost point, the velocity of the liquid is 0. So if r is 0, then at the axis the velocity is v0, and when r is that capital R, r0, then the velocity is, or we can, what we can do, we can just integrate indefinitely. So v will be equal to c into r square by 2 plus some constant c0. Now at you can easily see that there would be a negative sign also, because there would be a negative sign here, because we know that dV by dr would be negative, because as we would be moving away from the axis, the velocity of the liquid would be decreasing, so there would be a negative sign. So here it is, and at r is equal to 0, v is equal to v0, so c0 is equal to v0, so v is equal to minus c r square by 2 plus v0. Okay, now we have to find out the value of this also, c also. So at r is equal to r0, v is equal to 0. So what we can do, that v is 0, so 0 is equal to minus c into r0 square by 2 plus v0. So c will be equal to 2 v0 by r0 square. So finally v would be equal to minus of 2 v0 by r0 square into r square by 2 plus v0. So cancelling this 2 with 2, v is equal to minus v0 by r0 square into r square plus v0. Now at r is equal to r0 by root 2, v will be equal to minus of v0 by r0 square into r0 square by 2 plus v0. So it would be equal to v is equal to v0 by 2. So this value of n will be equal to 2. Now this is the end of the question paper, and this is the answer key. You can take the screenshot of the answer key and you can check your answers. Thank you.